because the 20-minute slot is very tight. Merlin's hoping to have time for some questions at the end as well. Merlin is a software engineer at EIDU, where he makes learning easier for children in low and middle income countries around the world. His talk will describe the functional approach he used, or his team used, in making the learning platform local first, so that it could be reliable without depending on the internet. And I think that that's a specific use case for that problem, but I think all of us as responsible web developers should be less reliant on the internet being there all the time for us whenever we need it. So yeah, thank you very much.
Thank you. Yeah, I'm Merlin, and this is my first Lambda Days. I'm really happy to be here, and I'm excited to talk to you about local first development and about event sourcing specifically. First, I will tell you a little bit about the company that I work for, EIDU, and what we do, how we are bringing digital education tools to low and middle income countries. Yeah. Then I will talk about local first software and why it matters, why we specifically choose to build our learning platform in a local first manner. And I will talk about event sourcing, which is a paradigm that we use, and it's a data modeling architecture paradigm that I'll talk about, and also talk about how it ties in with functional programming. I'll also talk about the command query separation principle in the context of event sourcing. And I'll talk a little bit about Kotlin and functional programming, because while I've had the pleasure of working in pure functional languages, I do most of my work in Kotlin these days, and while it is a multi-paradigm language, it has some very nice functional features. And then finally, I want to talk about benefits and drawbacks of event sourcing to help you figure out, is it right for your use case? Is it something you want to use for your data architecture in a project? Okay, so let me start by telling you a little bit about EIDU. So EIDU was founded in Berlin 10 years ago with the goal of helping improve learning outcomes in low and middle income countries. These are countries where generally education systems are struggling to provide each learner with learning outcomes that are comparable to high-income countries, and these are also countries that are kind of in the infancy of digitizing their education systems. Like, that's something that governments have on their agenda. It's something that they want to invest in, but it is an area where they often lack the specific software or the specific tools that works for them. And this is something that we try to provide at EIDU. We digitize education systems in those countries. We started in Kenya, and we have 500,000 children learning there with us now. But we've also expanded to other countries, to Nigeria, to Pakistan, and we're going to keep growing. The learning impact that our program provides has been proven in randomized controlled trials that we regularly run, or regularly have outside agencies run for us. And in one such trial, we found that learning outcomes were improved by 0.52 standard deviations, which is a pretty nice result. And the EIDU program has been rated as a top 10% learning intervention by independent organizations. So a little bit about the learning platform. So the client is built as an Android app, which is how we distribute the platform to schools, because bringing digitalization there also often means bringing the devices. There are no computers in those classrooms, there are no tablets. And to do that cost effectively, we've built that as an Android app. The app, we try to provide a holistic approach to education. So we provide things for the pupils, for the children, little learning games, learning exercises to supplement the education they're getting in the classroom from the teacher, digital lesson plans for the teachers to help them. It says learners here on the slide. It's meant to say teachers. Digital lesson plans for teachers to help them run their lessons more effectively. And we also perform digitized versions of standardized assessments to measure learning outcomes and to continuously improve the material that we offer the children and teachers. We also more recently have integrated AI models into the system to optimize the learning path for each child based on their learning history, and some AI-generated content that is tailored to children when they're struggling with a specific topic. So why local first? Local first software is a term that's relatively recent. It was coined by a research lab called Ink and Switch in 2019. And what local first means is that we focus on the local experience, that is the local device that the user interacts with directly, and that this device has kind of primacy. I'll talk a little bit about some of the principles of local first on the next slide, but first I kind of want to talk about the situation that motivates this. So for us at EIDU, that's we have many devices at a school. We have the school and learner data distributed across these devices, but we have intermittent or poor internet connectivity. Schools we cannot assume that a school in, say, rural Kenya will have Wi-Fi. Internet connectivity via mobile, as well as power, actually can be intermittent, and we need to be able to deal with that. And then, because we are building these things for governments, and because we handle the data that is about children that are learning, this extremely sensitive data, we need for our users, for governments, to be able to own this data. It cannot be something that lives on our servers. Although we do offer hosting things on our servers, the actual primary copy of the data cannot be that. So local first, there's a bunch of principles that Ink and Switch came up with to describe local first software. I will not mention them all, but I can recommend reading the paper that they published in 2019. It's a very good one. So the key points for us here are that we want an experience without delays. We don't want to hit a button in the app and then it needs to fire off a network request somewhere and there's a delay while that happens. So changes need to be made instantly for the user. We want full offline capability because it might be that we go a few days without an internet connection. And that time we still need to provide all the features of the learning program to the school. We want the user to have control over their data so that their data is under their control on their device and can be used without requiring a central server. And then, because we have many devices at the same school, we will want to be able to sync the data across many devices and have the users be able to use a different device for the same learner. So these are the principles of local first that are relevant to us. And now I want to talk about event sourcing. Event sourcing is an architecture and data modeling paradigm that we use and that lends itself nicely to local first software, although there are other approaches for achieving local first principles. The key idea of event sourcing is that instead of modeling data as records or rows and tables, if you think about like traditional relational databases, you might have a schools table, and each row in this table, each record represents a school, and we have all the like data for the school in there. In event sourcing, we instead model all changes to data as events, and as such, we also model all the data just in these events. So rather than having a school's table with say a name column for the school, we have a set name event that we emit, and the set name event tells us what the name of the school is. We organize these events into what we call event logs, or what is sometimes called event streams. These roughly correspond to an entity. So a school will have its own event log, a class at a school, a learner will have their own event log. And these events, they're immutable. So whenever data changes, we emit a new event. We don't edit the old events, and we basically have this append-only database of events. And that describes the entire history of the data, rather than the current state of the data. So we don't have to build, say, a separate school history table that has school records that are versioned, but we basically get versioning out of the box. Again, with the example, we in a relational database, we would have a schools table and a classes table. And in the classes table, we have a column for the teacher name and a foreign key for the school that the class is at. And in the event-sourced model, each class and each school will have their own event log. And we will emit add class, remove class events on the school log, set teacher name events on the class log to capture that data. This ties in nicely with another principle, which is called command query separation. Command query separation is a principle that was devised by Bertrand Meyer as part of his work on the Eiffel programming language. Basically, all operations that pertain to data are divided into commands that change state and queries that read state, which gives you better separation of concerns and can give you better query performance because you're able to optimize separate data models, one for reading and one for writing. And applied to event sourcing, that means that a command will emit new events. And queries could just read the entire event history, but that's not going to be very performant when the event history is long. So there's a better way, which is having a separate read model where the current state is captured as a projection of the events. And the projection might actually look like a relational database, and we might actually then have a schools table and a classes table. But these are not the source of truth. These are just projections. They can be considered cached data that we create by replaying the event history, by going through the events each time and applying the data to the tables. So we also get basically time travel features where we can flick through the event history and see how it changed over time. And it's also interesting when it comes to data migrations because, of course, we can migrate the projections database when our data schema changes, but we might also choose to just recreate it because it's not the source of truth. We can recreate it at any time from the events. And then we don't have to write explicit migrations for this table. Now, for the functional programming aspect of this, and this is where I want to draw an analogy with the kind of relationship between state and UI in functional apps. I think something like Elm or React Redux, Jetpack Compose, where we have a pure function render, which takes some state and provides the UI that corresponds to that state. And where we can have a pure function also to update state, where we take the state and some kind of external event, like some user input, and we emit another state. There's a nice analogy here with event sourcing, where we have our state, which is rendered by a pure function into UI. And then based on user interactions, we emit events and commit them to the event history. And then we have a pure function from the event history to the projections table, where we materialize the events. And we can query the projections table reactively to derive our current UI state or application state. This is something that works really nicely in a functional way, and where I think event sourcing offers advantages over different ways of syncing data. Speaking of syncing, so syncing data between devices is also accomplished just by exchanging events, which makes it simple and robust, because the events data that we exchange is much more granular than if we just update entire records at a time. So we have better conflict resolution. Brief look at Kotlin. I noticed that I'm going to run out of time soon. And I want to leave a little bit of time for questions at the end. So yeah, we built our Android client in Kotlin. We also built the backend in Kotlin. And as much as I love purely functional languages, I'm actually pretty happy with how that's working. Building the backend in the same language as the client gives us a bunch of benefits when it comes to context switching and code reuse. And yeah, Kotlin does have great support for the functional paradigm. Immutable variables are idiomatic and the preferred way of doing things. Data structures are immutable by default. Tail call optimization is supported. And then if you want to get the advanced functional programming features that you might be used to from a language like Haskell, the ArrowKT library provides some excellent options. Yeah, so much for Kotlin. Then kind of a little bit about the benefits of event sourcing. So basically we get an audit log and a history of changes just straight from the data model. We don't have to think about versioning. And once you get used to it, this modeling data changes as events is pretty natural. It also ties in nicely with domain-driven design, which also has this philosophy of considering data through events. And the separate read model with the command query separation allows us to be flexible with our queries, to optimize them without having to consider the right model. We might not need database migrations for our projections. And we have this higher granularity by modeling each separate change to the data as an event, as opposed to modeling versions of records or rows. Yeah, which gives us better conflict resolution and the foundation for a sync protocol. Yeah, event sourcing also lends itself nicely to event-driven architecture. So if you have a microservice architecture with something like Kafka stream processing, then you're basically already there. You don't need to think about how your data model is going to map to Kafka streams. And you get eventual consistency, which yeah, is in a distributed system a good thing, because you can't get immediately consistent data across devices, but you can eventually consistent data, so you're ensured that on multiple devices will always agree eventually once they've processed all the events about the state of the data. There are a few drawbacks or challenges in implementing event sourcing. So this read-only, append-only database of immutable events, it does mean that any design decision you made about an event, it's going to be there in your event history and it's not going away. So when you come up with new versions of the schema, new versions of the events, your old events are not going to change, and you still need to account for them. You still need to have some compatibility mechanism to deal with the old events. On the other hand, you are free to evolve your projections table in any way that you like, because it is ephemeral. It's just something that can be recreated at any time. It is an additional abstraction layer, so if you're used to thinking in relational terms, then you're now maintaining two data models, an event-based one and a relational read-only model. And the event history may become very large over time, because versioning is not something that you consider when you need it, but versioning is something you always have built in, so you're always also taking up space with your data versions. Yeah. Then I'm at the end of my talk, and I will happily take questions. Thank you for listening.
Thank you. Do we have any questions? Yeah.
What you do when the event history becomes too large?
When the event history becomes too large?
Yeah.
Mm-hmm. So there's different approaches. It's possible to make snapshots of the event history of the state that is implied by a certain chunk of the event history. And you can also put these snapshots into events if you wish, so that basically you're able to disregard chunks of event history and have the snapshots available. Are you thinking about, is it like a storage problem that becomes too large, or a processing problem? Storage? Yeah. Especially on mobile devices, I get it. Like storage can quickly become a problem. But the thing is, you can selectively forget events. You don't need to keep all the events that are in your system on the local device, because you have the separation into event logs. So you only need the events for the logs that you're interested in. And for many event types, you might only be interested in the latest event. For example, like a set teacher name event, you don't need the entire history perhaps of teachers that the class has had, but you just need the current one. So you can also selectively forget events on your local device.
Right.
Yeah, which of course is a trade-off.
Great. Thank you. We are out of time.
Thank you.
Yeah.